Hey everybody, welcome back. We're going to be looking today at proximity interactions. So this is going to allow us to have a player that can walk up to something, get a prompt to press a button, and when they press it, it'll interact with the object in the respective way. And let's get into it. So there's a few tabs that we're going to work through here to look at the different elements of what this is, but most of these are actually foundational for things that we've already set up. So an input interaction is necessary to control when we're going to interact. So set up an IA. The IMC should already have all your player controller information on there. We're just going to add the IA for interact down there and assign it to a value. And then when we get to the player character, we're going to set up an event dispatcher by clicking plus here and then adding a dispatcher. And I call this one proximity interact. So we're going to say that whenever the IA is fired, then we're going to call proximity interact. And this is going to send a message out to anyone that's a subscriber to this. So this will be our interactable objects. And that's all we really need to do from the interaction standpoint for the player. Then we want to figure out how to convey that information to the player. We have our HUD, and so we have some objective details up here, and we have this interaction prompt. It's just a text widget that I've added here. I've turned it into a variable. It has a default text value here. We just set that to none because you're not going to be interacting with things off the bat. And then over in the graph for that, we have a function called update interact, which is just going to take that prompt text and set it to whatever our text interaction prompt. So this variable that we have here, we're going to pass in the value for that on-screen widget to update over time. So each object has a specific thing: collect, destroy, open, close, shut, steal, whatever that is, that'll be passed through here. We don't have to do it this way, but we are using a blueprint interface. And so I have an update interact prompt, which is just going to be passing through a prompt text, which works out well because that's all that we're going to need for this. That BPI is already implemented on our HUD system. So when you looked at the HUD in the class settings, you can see that it has the interface implemented over here on the right side. Then over here on the left under interfaces, we can see the different versions of these things. And so if I take the interact prompt, when I pull it out, I already have it implemented, but I can right click implement interface, and that'll give us this one with this special icon that we have right here. With that icon that tells me it's going to receive a interface call, and I can send that without having to get a direct reference to the HUD, but we are going to do that in this particular case. So in this event update interact prompt is going to call the update interact for the HUD reference. So this BPI, this interface, is going to be calling the function on our HUD class, or our HUD widget class. So assuming you have that set up correctly, then whenever we make a call from any actor anywhere, it will update this thing appropriately. That's how we convey the information to the player. So we have the input and the conveyance set up. Now we're going to go set up the actual recipients of these elements of interaction and allow them to be configured in a way that will communicate to the player what it is that they're allowed to do. So the first thing I have is this activated actor. This is an actor that we've created a long time ago. This is just our default actor class. So we have activate as the default function that we have here. I've expanded this out a little bit in some other videos to show some different approaches to how you would do this. But for the activate, basically whenever this gets called, we're going to override this in any child class. So this BPA is an abstract class activated actor. I have from that class, from the BPA activated actor, you can see up here, that's the parent class. I created this BPA proximity interaction target. Naming conventions could use some massaging. What's going on in this class is that we're going to be taking a look at the player character because we set up that dispatcher in there already. And the dispatcher is, to look at again, is called proximity interact. And so this is going to call or send a message to fire off any event associated with this in any subscriber. So for this class, we're just setting up to get that player character reference immediately. And then when we say bind, we're going to bind this event here to that proximity interact. So we're now subscribing to that. We're listening in for that dispatcher. So when that dispatcher gets called, we're going to fire off this event, which is basically just going to check our own variable. If we're interactable, set to false by default. If we are interactable, then we'll activate, which is the function that's called in our activated actor. And then we're going to update our interact prompt, which is going to fire off this interface, which is going to look at the HUD reference and say, hey, send off this detail. So the prompt to interact is going to generate or return to nothing after we've interacted with it, so that we don't have anything lingering on the screen. And then I've opened up this thing for additional interaction, which basically will allow us to call additional interaction on anything that has subsequent effects, and we'll see that in kinematic door in just a second. The way that we're controlling all of this, whether or not the object is interactable, is actually over here. We have a sphere trigger, which is going to, or sphere collision, which is going to act as a trigger for us. We're just setting this up with a radius of whatever size you think is appropriate for the object you're going to be interacting with. And then I have two events that are tied to that. I have the event on begin overlap and on end overlap. I'm just checking the reference to the player that we already casted to. So we casted to the player character here. If that's true, then we have this check. And then if that check is true, then we're going to check to see if we're going to make sure that the object is now interactable. And then as soon as the player leaves that environment, then the object will be no longer interactable. When they're inside of it, they'll get the text prompt on screen. And when they leave, the text prompt will be empty. Now, there are some hiccups that you run into if your character can be destroyed during gameplay. So if that is the case, then you just need to set up something where it checks for the player character on spawn, and it will bind to on event destroy for that, and it'll just reassign the player character whenever it respawns in. And so just be mindful that there's some considerations in your unique implementation. So with this set up, that basically handles all the elements that I would expect. My interaction prompt is just something that I attach. I set it to interact by default so that you can interact or activate whatever it is that you have. We have these two references and the interactable variable. With that in play, what I was able to do is then make a child actor of that class. So this was the proximity interaction target, and then this one inherits from the proximity interaction target. And I've added these two events. So there's collect pickup, and then it'll destroy actor after we collect pickup. So whatever this print text is, this will do the thing that it's supposed to do for the pickup. So if you have a pickup that has a varied set of abilities, you can create the apply pickup function here and then inherit any number of children or sibling classes from that to implement the variations that you need for that. So this is just a pickup parent class. So once I do that, I can add the object into the scene. And you can see here I've chosen to, for that particular class, I chose to give it a static mesh reference, and I just use the chamfer cube. So with this, when I go to play here, if I walk over it, I'll get collect, and it goes away when I step in front of it, and when I collect it, that goes away. Now, there's a limitation here with proximity interaction, and this is generally true without a more refined system, but there's a design consideration that you don't have multiple objects that are close enough in proximity that I could do this, where I pick up two objects with the same input, unless that's a design feature that you want. Some games that would have you have a lot of things to collect, sometimes they'll just allow for a hold to expand interaction radius, and then you can attach the interaction radius to the player, and then as it overlaps with objects, then those objects will be turned on or off for interaction. Now I have this other interaction over here, this door. This kinematic door, if I go back to this class over here, this kinematic door also, it comes from the kinematic base. If I open this up, which was just something we had that moved around, and I just decided to make that inherit from the proximity interaction target. There's obviously different needs for doors that are proximally interacted with versus remotely activated, and that's of course something you're gonna need to consider for your project. But this kinematic base just moves something over time to a different transform, and the kinematic door is looking for the begin overlap to check for the player. It's going to unlock or a lock, and I've extended this additional interaction feature, which we added right here. So this in the proximity target class, I added this additional interaction, and so for the door here, I just have it the first time they interact with the door, it'll change the interact prompt to close, and the next time back to open, and it'll flip-flop between them, so that when I come over to the door, it'll say open door, and if I reactivate my interaction prompt, it'll say close door. And the whole thing, because it's derived from the same hierarchical chain, right? These the kinematic base is derived from the BPA proximity interaction, which is derived from the activated actor. I can have shared functionality between all these things where I make one modification, it shows up everywhere else. Some people are probably wondering if this is a performance system. So what I have over here is a collection of interactors, and I'm going to just activate my stat FPS. You can see I'm capturing and running, and there's a few other programs in the background. So I'm running at a 54 frame right now, but that's not because of the objects. That's just because of my system. But if I go to interact with these things, you can see the frame rate is stable between them. And that may not look like much until you realize that this is actually 200 actors. So the idea that I have these things grouped here, if I go to groups and I say ungroup them, you'll see there's a number that I have here just stacked on top of each other. You would never have noticed with all the interactions that are going on. Frame-wise, you can have thousands of these things in scene, and it will not make a difference because the actions are not going to go beyond the check for the collision to see if the thing's interactable or not. So when the dispatcher calls, it's only going to fire a quick look at the object, and it will not have any impact on other physics considerations. So hopefully this gives you an idea of what you can do to set up proximity interaction inside of your game, allows you to go out there and keep building.